So those would be the two types of energy: potential energy and kinetic energy. All right? Now, we're going to focus upon these two types of energy in this chapter. Chemical energy and thermal energy. Those are the two that we're going to focus upon. So, like Jay said, that if you got petroleum, it has a chemical energy. Today, I'll do a little demonstration for you here before you go. And we're going to take stored up energy here in this. What is the stored up energy in here, by the way, do you think? What do you call it?
Nutrients.
No, there are not too many nutrients in this.
Flavor. Artificial flavor.
No, sugar. Right? Sugar. That's the energy that's going to allow me to do the reaction for you guys later on. Sugar. Okay? And it is a hydrocarbon. C6H12O6 is a simple sugar. So, chemical energy. Now, we're going to take a look at chemical energy and see how we can look at the molecules to see what happens to the molecules to create the chemical energy. Thermal energy, we've dealt with thermal energy in the last lab, right? Which one had the greatest thermal energy? What was the best source of thermal energy in the lab?
Bunsen burner.
Bunsen burner, right? That was our best source of thermal energy. What was second? You remember?
Ethanol.
Ethanol. What was worst?
Candle.
The candle. Right. So we have, candles used to be really important for lighting. Okay, now candles are just like you put on the birthday cake, right, to blow out, or to do a lab like we did, or for senses. You guys have a sensei or whatever they call it? Sensei? They're based upon wax, right, and the odor's in the wax, and when you burn the wax, the odor comes out over a period of time. So candles are something that used to be a lot more important, and now they're not near as what they were used a while back. So, thermal energy we're going to talk about quite a bit. So chemical energy is a form of potential energy that's stored up in a chemical compound. And glucose, like you guys ate today, it goes to our cells and it's used up by our cells. And then thermal energy is the energy that will increase the temperature of a substance. Okay? So those are the two we're going to focus more of our time and attention on. There's two types of thermal energy, or thermal processes. Endo, and it just, what you think endo would be, energy goes in. So endothermic is energy going in. Okay? And exothermic means energy is exiting. So you have endothermic and you have exothermic. If we go into a house, that means we're taking ourselves into the house and we're going in. So endo, always think endo is going in. Energy is going in to what we call a system. We call a system is something that we're looking at. So if we go into a house and our body warms up, our body's the system because our body's getting more energy from the warmth of the house. So that's called endothermic. Okay? That's what that would be. And exothermic is energy is going to be taken out. So if I go outside on a cold day, energy is released from my body to the outside. And so energy is exiting from my system, from my body. So when we talk about this in AP chemistry, we talk about the system and we talk about the surroundings. So the system is the chemical reaction, and the surroundings are what either gain or lose energy. So the surroundings. So when you burn a candle, is the surroundings heating up?
Yeah.
Yeah. So the surroundings heating up. Is the candle losing energy or is it gaining energy?
Losing.
Losing. The surroundings is gaining energy. So it depends upon what you're talking about. If you're talking about, like if I get in a shower and it's cold for some reason, okay, the water hitting my body is going to start cooling down, so my system is cooling down. So that would be energy is taken out of my body. And so for my body, it's exothermic. My body's heating up the water. And the water's heating up. Because if it's cold, it's going to heat up a little bit when it hit my body. But if it's hot, if it's a hot shower, you turn it on really hot and you get in there and it's steaming, your body is warming up. So energy's going in your body, but the water's losing that energy by giving. So we got to just practice to know what we're talking about. We're talking about a system, or we're talking about the surroundings.
Does Ben use all the hot water?
No. No.
No.
Types of we're going to do a really neat lab, and I like it, and you guys will probably like it. Most of you will too. And this is the lab you're going to do. You're going to go home, and you're going to write down every time you use water and how much you use. And there's easy ways to do that. So for example, one of the things was that I had a girl in here, I think when we first started this class, we started this chemistry class about 4 or 5 years ago. And she actually said, and then you guys don't raise your hand if you do this, okay? Because, you know, it's a waste of resources and that. But she actually said she was in the shower for 30 minutes. She took a shower for 30 minutes. Anybody in here take a shower for 30 minutes?
I exactly.
No, I don't.
You take a shower for 30 minutes? Does it go cold
No,
while you're in there?
I probably like a 10-minute shower.
Yeah, I would say 30 minutes is like, that's like a Wednesday class time.
No, it's okay. One time I was in there for 2 hours.
How could, I mean,
I was like,
there's no
"Fine."
way you could have enough.
That's fine. I like, okay, when I was, yeah.
Maybe 3 minutes and I brushed my teeth.
Yeah, I mean, it's just like, I'm in there.
I mean, I've been in the shower 30 minutes one time.
Yeah, but
You guys.
it might be one of those things where you're really cold and you go in there to warm up and it just feels so good.
Oh, yeah.
You're sick. When you're sick.
Oh, yeah.
Or you're sick.
Okay, well, like, how do you have time to shave your legs and then...
Oh, well, I don't shave my legs. So.
See, that's the thing I don't shave really either.
I know.
I can take a 10-minute shower. but
I know.
shave my
Don't
legs
say it,
takes
brother.
like 30
I know.
minutes.
You know what I'm saying, John?
Okay,
John knows what I'm saying.
so these are processes that will be endothermic. Okay, now let's look. Ice melting, does it change in temperature?
Yes.
Mm-mm.
The ice don't change?
You guys remember we did that graph when you guys were freezing and melting ice and water? Did it change in temperature?
The ice?
Yeah,
Oh, it don't change how it turns to water.
right. So as ice melts, it doesn't change the temperature, but it's still gaining energy.
It's gaining energy?
Mm-hmm.
How?
It's
Oh,
gaining energy
okay, yeah.
to move the molecules faster. Or change them from a solid to a liquid. Okay, boiling of water. What is it? The water is a system, you're putting energy into it to boil it. Breaking bonds, this is what we're going to talk about. Bond breaking. We're going to break bonds when we do a chemical reaction. The one I'm going to show you is going to break bonds. It's going to break sugar bonds. Okay? Now that takes energy to do that. It takes energy to take bonds apart. It's kind of like pulling a magnet apart. Okay? Or taking something sticky off of an envelope, like a stamp. It takes energy to do that, to break those bonds. Okay? So those are all endothermic processes. Okay? Can you tell me some exothermic processes where you get energy out? Can you think of some exothermic processes where you get energy out? Uh-huh. When you take energy out. So, here's some, should be exothermic up there. I think I copied it. These are endothermic. Energy's going in. This should be exothermic, so make sure you write types of exothermic. And I'll change that later. So it should be types of exothermic processes. To freeze water, you have to put it in the freezer. The freezer is colder than the water. So heat is taken out of the water until it gets the same temperature as the freezer. So that's an exothermic process. The water molecules start to go slower and slower and slower. Okay? Condensation of water. Okay? When it's steam in the room, like if you take that long shower and there's steam in there, where does it condense? On the mirror. It condenses on the mirror. Why? The mirror's colder than the water in the air. So it's going to condense. You get up in the morning and sometimes there's frost on the lawn or dew on the lawn. It's wet. It's because the ground was cooler, and that's where condensation took place. Okay? And then also, an exothermic process is when bonds, this is forming of bonds. Instead of breaking bonds, we have an exothermic process that would be forming of bonds. So when bonds form, we get energy out. Bonds go together, energy goes out. Pull them apart, energy goes in. So we've got endothermic and exothermic. Questions? So far we have talked about potential energy, kinetic energy. We talked about chemical energy, thermal energy. Okay? Now we're talking about endothermic and exothermic processes. Thermal means heat, right? Right? Heat energy going in or going out. Take some time. I want you to write this down and we're going to talk about it. So chemical reactions. They're going to both have endothermic and exothermic taking place. Okay? Endothermic and exothermic has energy taking place. So go ahead and write that down. That's the endothermic process. Got to break those bonds, and then they're all separate atoms. Okay? Now, this is what happens to those separated atoms. This is the exothermic process. Bonds form. So they're separated out. Then they decide we're going to get together and we're going to form a new compound. So here's CO2. It's double bonded. Carbon's double bonded to oxygen, both of those. And then here's water where you got single bonds. Okay? So when you did the Bunsen burner, okay? When you guys ran the Bunsen burner, that's the reaction that you're doing. You're breaking them. And then you're putting them back together, and guess what you get out? You get energy out. So you make energy. I shouldn't say you make energy, but energy is transferred from the chemical form to the thermal form. Heating. So you're transferring from chemical to thermal in the process. So this is the exothermic process. Okay? Now, if you had your book, there's what we call a potential energy diagram that you would use. Okay, so a potential energy diagram is just what we have here, but it's just shown in a different way. And it's shown all together. Okay? Can you guys see that, or do you need me to blow it up a little bit?
I can see that.
Okay? Uh-huh. So I'm going to go ahead and blow it up a little bit for you. basically up here I can find where I can increase it, but maybe I can go control positive, and that'd be fine.
I'm probably sure.
That guy?
Yeah, let's sure.
The orange or the salmon or the blue?
The blue.
Or the combo?
Yeah, the blue, they go them together, but I mostly like the blue.
How much it does it?
This sure does feel like peanut butter and jelly.
Okay,
I like it with.
this is the last thing we'll go through here today. Okay? Now, the reactants are down here. They have a low, so this is high potential energy at the top, and this is low potential energy. Okay? So this line represents the energy at this point in time. So CH4 plus 2O2, this is the energy it has. Okay? Now, what happens to the energy, potential energy? Does it increase or decrease from the beginning to this point up here?
Increase.
Yeah, so the potential energy increases. So you have to put energy into it.
Take energy out.
Well, you have to put energy into it to break the bonds. And that's what these are here. Bonds are broken. You put energy into it, you break the bonds. Now it has a higher potential energy. It's kind of like a roller coaster. You go, start down low and then you go up. So it has a higher potential energy. You put them together and then you end up with a lower potential energy than when you started. So if I have it's like a roller coaster. If you start at a certain height, go up, and then go down below the point which you started, you get more energy, more speed. Okay, you go up a hill, you go up a little hill, you go down a big hill, at the bottom of the big hill you're moving really fast. Okay, same thing with this. If the potential energy at the end is less than the potential energy that we start with, we get energy out. And that's called an exothermic process. So this is an exothermic reaction. We should get energy out. We should get thermal energy out of that when we do it. Okay? And then I will put the other one up, but I'm going to start the demonstration before a couple of these guys got to go. So this is one part, and I'm going to show you the endothermic so you can write it down, and then we'll talk about it tomorrow. But that's the exothermic. There's another one that's endothermic too.
Baseball. So we done with notes for there?
Well, you didn't take any notes, but
Yeah. Just
3 notes.
potential kinetic energy and chemical reaction. Car wash.
Are you gonna put the other one up at all?
Yeah, I will. But there's some people copying it here. So. Yeah, I can put the other one up right now.
Sorry, but you don't have a good imagination, Tyler. Thanks, dude. It really made no difference.
Here's the other one. This is a different reaction. We'll talk about it tomorrow.
Yeah, no problem. What? Did you just want to die in a house fire? Pretty sure he said die in a house fire. I'm pretty positive. Guess what, Mr. Garland? I saw John Martinez Friday night. Good old guy.
Wow, really?
Yeah.
Wow.
I saw Kylie last
Holy
night
cow.
and this morning.
Oh yeah, so this one too.
Yeah.
Did you see me last night?
Yeah, you were with Isaac. You guys